Hello. So in this video, I'll be working through some mensuration problems from IGCSE Maths. So the first question, we're given a circle of radius 9 centimeters and center O. And a minor sector is removed from the circle. So the minor sector is this one here, AOB, this one. It's been removed from the circle, and that has a measure of 50 degrees. So it says to calculate the length of the major arc AB. So this is terminology we need to know. Major arc. The major arc would describe this part of the graph right here. It would describe this part of the graph. AB, but the side which is longer, because there are two ways to define AB. You have AB like this, which is the major arc, and you also have the minor arc, which is this part here. This dotted line is the minor. This is the minor arc. Since its length is less than the major arc. But this question we're only asked for the length of the major arc. So we don't have to worry about the minor arc for now. So to do this, we need to firstly calculate this angle here. And that would be 360 minus 50, which is 310. Since a full rotation in a full circle is 360 degrees. So now that we have that 310 degrees, the way to do these problems is to think of the major arc as a fraction of the circumference of the whole circle. And the way you calculate that fraction is by the angle, which is 310, divided by the whole circle's angle, which is 360. So then the fraction is 310 by 360. That's the fraction of the circumference that the major arc occupies. And we should know the how to calculate the circumference of a circle. That's just 2 pi r. And here we know that r is just radius, which is 9 centimeters. It's given in the question here. So we can replace the r with 9 centimeters. And that's it. We can just put that into a calculator. And you should be getting an answer of 48.7 centimeters to 3 significant figures. You should always give your any length or those kind of measurements to 3 significant figures and angles to 2 decimal places. So let's write that. That's 48.7. That's the answer. There's actually another way to do this, which is complicated. It's more complicated. It's to calculate the length of the entire circle, which is 2 pi r, and r is 9 in this case. So 2 pi times 9. That's the circumference of the whole entire circle. And then subtract the minor arc. Subtract the length of the minor arc. So if you take the whole circle and subtract the length of the minor arc, you'll be left with the major arc. So that's another way to do this. And we know that the minor arc is, again, it's 50 degrees, so it's 50 divided by 360 as a fraction of the circumference, multiplied by 2 pi times 9. This is 8, so, and then we subtract it from the initial circumference, from the entire circumference. So that would give us 18 pi from here, which is the entire circumference, minus the length of the minor arc, which is this part here. And you'll find that if you put that in the calculator, you will also get 48.7 centimeters as our answer, which is the same as this. But I just think that this method is quicker. So this is the second problem that we were working through. So we're given a right angle triangle, and they've given us the area of 60 centimeters squared. And we're asked to prove that this quadratic is true. That we have this equation that holds. So firstly, it's asking us for the area, so we should write down the formula. the area of a triangle is 1/2 multiplied by its base times height, where the base and the height are perpendicular. That's important to note that for all triangles, like the base and the height must be perpendicular so that the formula, you can use it in the formula. But we don't have to worry about that here since it's given to us that this is a right angle triangle. So all we have to do now is just substitute in, label the sides, base and the height. So AB is the base and AC is the height. And now we can just substitute that in. So the area is equal to 1/2 times the base, which is AB, 2x plus 5. And the height, which is AC, which is x plus 3. So, but also we know that the area, they've given that the area is 60 centimeters squared. So we can substitute that in here for A. So 60 is now equal to this expression. And now, to neaten this up, we have to multiply both sides by 2. So that the 1/2, because 1/2 times 2 is just 1. So after we do this, the fraction will go away. So that becomes 120 equals to 2x plus 5, x plus 3. The 1/2 isn't there anymore because 1/2 times 2 is just 1. So now we just have to expand the brackets on the right hand side. We get 120 equals to 2x squared. The way to expand the brackets, you should know, is multiply this first, which is 2x squared, and then multiply 5 and x, which is 5x, and then multiply this, which is 6x, and then finally multiply 5 and 3, which gives us 15, plus 15. So 120 equals 2x squared plus, let's collect like terms here. Like terms, 11x plus 11x plus 15. And therefore, if we subtract both sides, if we subtract 120 from both sides, we get 0 is equal to 2x squared plus 11x. And so we subtracted 120 from both sides. And 15 minus 120 is negative 105. So now we have this here, and that is exactly what we're being asked to show that 2x squared plus 11x minus 105 is equal to 0. And we've done that here. So yeah, that's it. That's all you need to do for that question. I hope this video was helpful. If you found it helpful, please like, share, and subscribe. And please put down any other questions you'd like me to go through in the comments, and I'll be more than happy to help. Thank you very much.